Hello guys, I'm back with another video. We did previously two videos on question 1 to 10, okay, from Math League contest, a grade 5 to 6, second round, and January to February. And I did question 1 to 5 in one video, 6 to 10 on another. And today we're going to do 11 to 15. Okay. Let me make myself a little larger too. Okay. So let's find question 11. Okay, there it is. I think we could make it a little larger. Okay. So please pause the video and read the question, even if you have read it before. Read the question, pause the video, and then play it once you're done. Okay. So this question basically says that the sword is a straight line. Okay. And then we want to place it through the box. Okay. The sword or the line is 70 centimeters long. It's going to be here. And then we also have the measurements. There is a 40 and 30 and 50. So for example, this line would be 50. This one is 40 and the other one is 30. Is there a way to put the sword completely through the box? This is 40 centimeters. I think a lot of you can answer the question because it's probably one of the easiest questions here. So it's easy because the largest line we could draw here is going to be this diagonal. We're going to go from this side to this side. It would be the lengthiest one, the longest one is going to be this. Okay. So, and how large is this? It's going to be a square root of 30 squared plus 40 squared and plus 50 squared again. And you could use, I'm going to use my calculator. If it is something larger than 70, then that's the answer. The answer will be yes, it is possible to put the sword completely through the box. So 900 plus 1,600 plus 2,500. Okay, it's going to be 5,000, and of course it's going to be larger. Okay, so square root of 5,000. Okay, so yeah, it's going to be 70 point something. So this line is bigger than 70, so we could put the sword completely through the box. Will the sword fit in the chest? Yes, because this number over here was larger than 70. Okay. So let's move on to the next question. That is one of the best questions here. I really enjoyed it, and I'm not gonna fully spoil it. So if you have the question, the answer to this question, please leave it in the comments. It's very interesting, even if you don't care about this contest. It's a very great puzzle. So please pause the video, read the question for yourself. So basically, that's a puzzle, okay? And it means it's talking about maybe learning mathematics, or maybe it's talking about fairy tales, logic, and physics. Which one is it? And my suggestion is focus on the smaller words, like 2-letter words, because this JG is one of the 2-letter words that we know what it is. Maybe how can we start a new sentence? Maybe it's to. Can we start a sentence with B? No, I don't think so. Can we start it with F? So I'm not gonna give the answer, but here, these words, okay, as a hint, this word is one of these words, and this word is one of these words, right? So find it out, and if you have the answer, put it in the comments, okay? So we're gonna move on to question 13. Okay. Again, I need you to read it first. So pause the video. Okay, and then let's read this part. And the last part. Okay. So I will try to explain the question as well. We have 10 places, and we could put any numbers in these places, right? So for example, if we have all these boxes, how many of them do we have? We have 10 of these, right? 6 extra. And then another 3. And then we have a 4. So we have 10 places. And we could put all these numbers randomly, but we can't repeat the numbers. So I can't put 6 here and then 6 here. No. But I could put 6 here, 1 here, 7 here. So we have 10 places to put 10 numbers in them, right? So I think it's going to be easy. So how many configurations do we have like this? For the first one, we have 10 choices. We use one of the numbers already. So for the next one, we'll have 9. For the next one, we'll have 8, and so forth. So it's going to be how many configurations? 10 multiplied by 9 multiplied by 8. So it's going to be 10 factorials. Okay, is the question over? Not yet, because here it says we need to be careful. We don't want rotations or reflections. Okay, and what does that mean? So for reflections, you see these two are the same, right? If this is 1, if 3 goes here, 2 goes here, 4 goes here, 6 goes here. Okay, it's going to be the same. So here, 1, 3, this one, 2, 5 will not change. This becomes 6, this becomes 4, and then this becomes 10, 9, 8, and 7. Okay, now these two are the same. So when we are writing 10 factorials, we're counting the same thing 2 times. And this is happening for all configurations. So we have to, the total configurations has to be divided by 2 because of reflections. And then we could talk about the same thing. You see, for, let me clean this first. Okay, for rotations, okay, for rotations, if this is 1, Okay, this is 2. This is 3. 5 goes here. I'm gonna clean this. 5 goes here. 6 is here. 4 is here. Okay, 7 here, 8 here, 9 here, and 10 here. These are also the same. All I did to this one, I rotated just this much. So 1 goes all the way like this. So that's 1. Okay, if I go another 120, that's again another 1. So, and then if I go here, it becomes the previous one. So again, okay, because of rotations, we're counting, okay, each configuration 3 times. Once a straight like this, once like this, and then once like this. It's hard to show like that. So we're counting it 3 times. So the total number would be 10 factorials divided by 2 and then divided by 3. That's gonna be the final answer. Okay. And question 14, I think, is an easy question that you could figure out on your own, but we'll do it here as well. So read the question. It's a small one. Okay. And let's pick a color. So we're gonna have a couple of a pair of dice. So the first dice can get the number 1, 2, 3, 4, 5, 6. And the second dice is gonna get the same thing. 4, 5, 6. So what is the total numbers? For the first dice, we have 6 choices. For the second dice, we have another 6. So the total number of possibilities is 6 times 6. Okay. And now we want it to be an even number. So let's assume the first dice shows 1. And then for all of these, 1 plus 1 creates 2, which is an even number. 1 plus 3 and 1 plus 5. Okay, all of these will create even numbers. So if 1 is selected, we have 3 choices. Okay. So I'm going to write it here. 1 times 3. So, or let's just write 3 choices now. Okay. And then the second one. What if we just, the first dice shows 2. Okay. This time we'll have 2 plus 2 is an even number. 2 plus 4 is an even number. 2 plus 6, an even number. And you can see here, the second one is going to be 3 choices. And this will continue for all these numbers. For 3 choices. For 4, 3 choices. For 5, 3 choices, and so forth. So I'm going to write, so it's going to be 3 6s. It's going to be 18 over 36. We could simplify this. 1 over 2. Okay. So that's, oops. That's going to be question 14, 1 over 2. And question 15 is, again, another fun question. So please pause the video, read it. Okay, question 15. Let's see. I'm going to do this. I don't know. Okay. So let's see. There are soldiers here in the forest, and they would see in a straight lines. What does that mean? For example, if there is one soldier here, he would see if there are other soldiers on this line, and he would see all the spots on this line, all the spots here, and all the spots here. Okay, so the next soldier could be in any three places. It could be here or here. Okay, so and now the question is, what is the maximum number of soldiers we could place? I'm gonna start off by maybe here. Okay, if the first soldier is here, no other soldier can be here, no other soldier can be here, nor like this, nor like this. Okay, that's here. And then the second one, I'm going to place it here. Okay, again, this one and this one, all of these are out. This one is out. This one is out. Okay. I'm gonna put the next soldier here. So no other soldier can go here. No other soldier can go here. Not here, not here. So what do we have left? I'm gonna put another one here, the fourth one. So no other soldier here, not here, not here. So you get the idea. You could continue this for yourself. Okay, so if you do this, the maximum number of soldiers I found was 7. Okay, you could try it for yourself, see if you get 7. Okay, so for example, the next soldier, I could place it here, and this next soldier, no other soldier can be here, no other soldier can go here, not here, and not here. Okay, so continue this, try it for yourself. I think the maximum you get will also be 7. Okay, that's enough for today and for this lesson. In the next lesson, we're going to do questions 16 to 20. Take care and bye-bye.